Welcome back to Inc. Today we have a non-inverting amplifier with a third resistor connected between Vout and Vin. This circuit functions as a constant current battery charger for Vin. Find the expression for the current I3 flowing through R3, and finally, where does this current flow? In this case, we're dealing with ideal, so the op amp operate in the linear region, and because of this, provided the negative feedback sets, or with negative feedback by virtual short, anyway, you could say it by virtual short, we can assign the voltage at the V plus terminal. We can assign that voltage to V minus. So in our case, we can say that V plus is equal to V minus, which V plus is equal to V in, thus equal to V in. If V minus is equal to V in, the expression for the voltage at V minus by voltage division is V in equals to the voltage across R1 plus R2 times V out. This is with reference to the voltage at V out. So another thing to look at in this case, we can see that for our problem, in our case, that we can simplify it a little bit more before I even say anything. We can just say 1 plus, well, I meant V out. So before we simplify that, let's find V out. So V out is equal to, because we want the current, if we want the current through R3, we know the voltage at V in, we know the voltage at V out. We can then use the difference between those two voltage divided by the total resistance in that branch. So thus finding V out. So V out is R1 plus R2 all over R1 times V in. So we can say R1 divided by R1, we get 1 plus R2 over R1 times V in. By that, the difference, so we know that the current I3, current through the R3 resistor, is equal to the difference between these two voltage at those points, which we can say V out minus V in divided by R3. By substituting in V out, factor in V in out, 1 plus minus 1 gives us, let's just do that. I know the math is pretty simple, but we have 1 plus R2 all over R1. We factor V in out, so we get minus 1 V in all over R3, and that is equal to V in times R2 R1 times R3. This is the current through I3. So that is the expression for the current I3. So now where does the current I3 flow? So we know we have by virtual short, we also know that the current into the V plus terminal, I plus, is equal to I minus, which is equal to 0 amps. So thus the current I minus is 0 amp, I plus is 0 amp. So thus the current I3 is flowing into the positive terminal of the battery. So thus I3 flows into V in. And that's it for that problem. Basically what we're saying is that current cannot flow this way. So if I3 flows, it has to flow through V in. And that's it for this problem. See you in the next problem. Bye.